type of structure, any structure that you are designing. So generally for the resisting the lateral forces, generally in the this steel type of structure. If you are doing the composite structure, then the condition will be different. For this type of structure, like see, if we have this floor plan, okay, and we are connecting, we have this beam and column arrangement. So generally for the damper, we are going to provide some kind of mechanical equipment. Okay, so mechanical equipment, we have to design that one as per some of the international standards, right? Like see, here we are going to fix the damper. So this will be our next type of structure. Okay, what will be the other next? So apart from this damper, we have the other one that is called Diagrid. Okay, so in Diagrid, you are already seeing this structure, okay, that are with the bracings, cross bracings. But see, what is the difference between this shear moment, what you call that, moment frame, and this Diagrid frame? So their outer periphery, try to understand, like see, we have this outline of the structure. So their outer periphery column are going to be inclined each other. Okay, it means the bracings you have provided in the simple structure, that is moment resting frame structure, here we have to replace that all the like straight column with the silented, or you have to give the inclined member. Got it? Hello.
Okay.
So in this one, what will be the say? What the things that we are going to do this with this type of structure? This one. So the our basic purpose is to check that whether this structure are efficient on the conventional type of structure. Like if we have this structure or this structure, what structure will you prefer? So generally, if you study in deep and if you analyze all the structure with all the details, required criteria, you will find that this structure are required less amount of material to construct, and also less amount of steel. Okay, so what kind of a structure we have? Let me summarize. And there are also, we have outrigger also. So one of structure that is called outrigger. Let me explain about that. So outrigger means, like see, this we have a structure. So at, like if we have height of 100 meter of the structure, okay, what we will do, we will just provide some kind of build. What is this build type? See, when you do the if you are aware of the pushover analysis, have you idea about the pushover analysis?
No, sir.
This is just a briefing. Okay, so like see, pushover, generally if you are designing the structure for like see, if you are dealing with the infrastructure project, generally their height is short. But see, in the case of bridges or in case of truss, so that truss structure you will count in as per the length, right? If we have 100 meter of length, 100 meter of length, so as per the structure point of view, you will consider that one as a tall structure, or you can't just, you can say that this is the tall structure or a high rise structure. So high rise means not only the building structure, actually whenever you are seeing any kind of structure, so that are cantilevered to the earth, right? Like see, we have this earth periphery. So earth periphery generally are in round in shape, right? So it means every structure you are seeing, you have to analyze that structure. So first stage is the study of their dynamics and their vibrations, right? Like their free mode vibration, that you are already taken classes for the modal analysis, right? So what happened when you go for the tall structure and we have the complicated type of structure, then we have to do this type of analysis, this pushover analysis, or that is for the collapse prevention. So according to that one, like see, if your structure are that stress strain curve are like this, so there will be hinges in the structure, right? Like see, here we have find it, some of the hinges are in the structure right here. So to avoid that deflection in the structure, what we are going to do, we will provide some kind of belt. Okay, belt means this belt may be with the shear wall, or RCC wall, or maybe with the steel sections. Okay, like if you are doing in the steel section, we can provide the steel plates, right? So these are some of the advanced things that we have to study. Got it? So like you are now studying the course, so basically what will be the conclusion for our building type? So first we have the moment frame. Okay, what was the next after moment frame? We have damper. Okay, as per the steel point of view. After damper we have Diagrid. Okay, after Diagrid we have some of the you can say out trigger structure. Next we have some kind of bundle tube or tube structure. Okay, so see, uh, we are studying our you are studying all the things in the SAP class also. Okay, but see, what is the basic uh, like things that we want to get with this one? So we want to summarize, okay, all the structure concept you are learning. We want to summarize that one. Miss Kachen, sorry, I think you have some experience in RCC design. Okay.
Yes, sir.
And Mr. Faz Khan, I think
Yes.
you have also experience in RCC design.
No, only steel and aluminum.
Only still see. And basically, you are doing some kind of facade engineering type of work. So for that point of view, these structure are also you have to study their criteria. Okay, so that will relate with our all the uh, you can say all the technique that we are going to learn, and especially in this Diagrid, right? Or in this not out trigger, in basically in Diagrid we can use also the grasshopper. Okay, to fix the that inclined member. Okay, but right now we will use some kind of uh, tools that you are already learning in Tekla and in SAP. Okay, so let me open that particular file. What things that you have to do in that one? I think both of you have ETAB also.
Yes.
So see, basically some of the features that are matching with the ETABs. Okay, but you can export import file from ETABs to another one. Okay, another ETABs to SAP also, and ETABs to Tekla also. Just wait. So basically in this one, you are seeing this structure. So their outer periphery, all the part is, this part is a steel member. Okay. So what you can say about this structure? This is composite type of structure. Okay.
Okay.
Because see, in Diagrid, when you deal with the Diagrid, so generally making the RCC column that are inclined, uh, it will more efficient. If you apply this steel part in our trigger system, it will be better. Okay, and we have in between we have this shear wall, or you can say the core wall arrangement, right? So this you can count in composite type of a structure. Okay, so here by this comparative study, this is just for the like elaboration of the of the structure system. Okay, so you will not only see the things that are generally with this type of a structure. Generally you will see most of the structure and the training are going on this type of a structure, right? Okay,
Okay.
but
Okay.
for this one we need some of the extra we need to put some extra effort. So first part is, see, first part there is the modeling. I know that making the straight thing in the software are very easy, But if you see their inclined members and some kind of curve member, it will little bit difficult. Okay. Generally, their Diagrid are, this will arrange like this. Okay. You are seeing that one, both of you.
Yes, sir.
Yes, yes.
So their diagonal members, you will see this steel part, their diagonal member are arranged like this. Okay. So what is their like structure system? So in between we have this that tube type of this one, right? And we have this inclined member. Got it? So first let me check that one into their original modeling file. That here you are seeing the screen with the tabs. Okay. So we have this plan view. I will open their story one. Apply. Okay. So here you can see this is the configuration of the structure. Fine. Both of you are seeing.
Yes, sir.
Yes, yes.
So in this one, in this one here you can see that they are generally outer periphery, that all are like that connect with the inclined member. Okay, so first critical part of this one is to make the member inclined. Okay, so both of you are able to do this one in SAP.
Incline members, how we can do, I don't know. That import and export only we made.
So in SAP, if you have to model this one, this all the members, how you can model this one? Their out trigger system.
No, have not done yet.
You don't
Um,
incline member. So there, when you open the E tabs, SAP, so there is already some template that are available, right?
yes.
Right.
So that features are not available there.
No,
Yeah,
no.
is there. Grid
Features
is there.
available, but not practiced.
Okay, not practice. Okay, just wait. I will check that one, or I will just. So see, now you can see some of the complexity of this training may get increased. Okay, because now we have to move for this type of structure. So first task for this one, we can do this modeling in Tekla also. I think Tekla will be better. Okay, but in ETABS it's quite easy. But in Tekla you can also do as per your convenience. But if you do in the Tekla, that will be very good for you. Okay, because you will able to do this practice. Okay, so now just let me introduce this structure. So first thing you will see that why we need this type of Diagrid structure. Okay, so you can conclude some of the points written here. Tall commercial buildings are primarily a response to the intense pressure on the land. Advance in material construction technology, analytical method, and structure system for analysis design accelerated the development of tall structure. Okay, so here you can see that why we are going to make this tall structure and this Diagrid structure. Okay, also we have second point is the lateral load due to wind and earthquake. See, this wind and earthquake, these are the two major part of the structure analysis and design. Wind and earthquake, these both are so much complicated. Okay, if you check the complexity in this earthquake part, as you will move into this structure system or structure design and analysis and design, you will see most of the influencing part are come from this wind and seismic. Okay, because see that nature of the earthquake forces are generally they are in function. Okay, if you are putting the gravity load that are in just like 2 kilonewton, 3 kilonewton, some of the numerical value. But wind load and the earthquake load, if you are go for the that dynamic analysis, that non-linear dynamic analysis, then generally you have to form the functions, right, for this wind and earthquake. So that will increase the complexity of the structure. So to resist that kind of forces, we need to develop our structure more efficiently. Okay, because if you develop this one, it might require lots of things as compared to this one. Okay, so let's see what is that things. The recent trends show that Diagrid structured system are becoming popular in design of tall building due to inherent structure and architecture advantage. There is some of the advantage to make this structure. Diagrid is an exterior structured system in which all perimeters, vertical column are eliminated and consist of only inclined column on the facade of the building. Okay, shear and overturning moment develop and resist by axial action of this diagonal compared to the bending of vertical column in frame tube structure. So this point will conclude you that why we are providing this Diagrid one and where we have to place this one. Okay. Again, we have some of the points that you can check here. Okay. I will just summarize this one. Here you can see that 20 feet, if you take the example of this moment frame, okay, we have 10756 ton of steel, and here we have more efficient, it means 8453 tons. It means it is lesser with the 20%, right? So it's saving
Right.
your material. Okay, see, and if you are using Tekla, so there is major benefit by to use the Tekla. You can directly estimate all the quantities just by one click on the tool we have in Tekla. Okay, so we can easily estimate how much tons of steel you are using in this structure and this structure.
Yes.
So primarily when you have to develop this structure, see, you don't need to do this, that structure. If you want to make this one Diagrid, you can just do this. But I will provide you the model to for the study purpose. Okay.
Okay.
Here we have the dimension of the building, that is 42 into 42 meter. Height of the building 82 meter. Number of story 25. So generally this is high rise structure. Okay. A story, that is 3 into 3.3 meter. Generally it will 12 foot. Type of structure, compare Diagrid structure and conventional. Degree of Diagrid element, it's on 63 degree. Okay. Their dead load are on the frame and cells and cladding. Live load we have taken 5 kilonewton per meter square. Load combination gravity plus lateral. So in lateral we can count the seismic and wind load.
Wind.
Okay. Type of analysis we are performing: static dynamic analysis, FEM model analysis, P delta. Okay, these are the analysis we will perform, and the code base. So we are doing this all the things with the Indian code, Indian standards. Okay, but see, if you increase this one 82 to 150 meter, then you have to increase the number of code also here. We will use FEMA code. Okay, some of the that high rise one IS 1600. Okay, that code also. And what is the material? So we are using M40 grade of concrete, M50 grade of concrete. Rebar we have this HYSD 500 and 550 steel. We are using 345, and non-structure wall we are using lightweight blocks, and glazing panel we are using glass sheets. Okay, their frame section specification are here. You can easily just sorry, you can easily count, you can easily find in any software, and you can make that one. Okay, so next you will see that these are their periphery, outer periphery, and you have to make that one according to that. Okay, and this is the internal view. Okay, so here, see, this structure you are seeing. Hello. So
Yes, sir.
Mr. Faz, now you can
Yes.
compare. You are also you are doing this facade engineering.
Right.
So how you can fix that what you call that glass frame here? Generally, I think
Glass.
it is on outer line. Okay.
Yes. Yes. Glass is fixed on aluminum framing, and
Mhm.
aluminum is fixed to main framing, either steel or concrete by means of brackets.
Okay. So here if we have to fix that one, so we can fix that glasses on their outer periphery, right? Like on this one. Okay. On their outer periphery, this column, inclined column, will get into inside. Or we can fix that glass either outer periphery or inner periphery. We have that two options. But what will be the better option? That we have to fix that one on the outer periphery. Okay. So here, these are there. This is there. With this 3 story, you have to incline this member with the 3 story. Okay. Their diagonal angle, their beams. This is the ring beams. So in first step, you have to practice the same kind of model. This one. Okay. So in that one, this green area, what you are seeing, that green area, this one,
Circle.
what is this?
Connections.
Connections. Yes. So that connections, or see, this we have the red part, that is the beam. Okay. This we have the beam, and this we have the Diagrid frame, and this part we have the connections. Okay. To connect that all the nodes. Here you can see that we have this floor beam, not the connections. These nodes. Okay. So this is the joining point. You can say that that is the connections too. Okay. But see, the connection part, first you have to analyze whole the structure. After that, you have to pass the members for that loads. Then we have to design the connections. Okay. Next, see. So these are the configuration of the structure. I hope both of you get my point.
Yes, sir.
Okay. So now see, according to till now you have a study about the, I think that modal analysis and loading part in SAP, how we can provide the frames load. Okay. Next part, you can you have to apply, there is forces that are in you have to make the combinations, load combinations. If you are aware of the ETAPs or in SAP, you have to make the load combination and you have to provide load according to that. So now see, that is so lengthy and processing part, you have to do that one. And see, by this model of this ETAP model, here you can see we have this load pattern and load combinations. Okay, here you can see we have different kind of load combinations, or in define you can check the load cases. Okay, so see, we have to make the load case, right? Here we have this dead load, live load, modal load, uh, SDL, super dead load, EQX. EQX are earthquake force in X direction. Okay. EQY,
Yes.
that is earthquake force in the Y direction.
Yes.
That RXS. See, in first one, what is the difference? Let's see why this. Why you have to understand this one, because this is very like knowledgeable part. Because see, here you are applying the forces in two form. First one is the linear static, and second one is the dynamic. Okay. So first one we have linear static. Second we will have linear dynamic.
Dynamic.
Okay. So what is the basic difference? So see, whenever you are applying forces in static mode, so generally their functions, uh, we have two kind of function. In that one you can find time history method and response spectrum. So we have to form two kind of load cases. First we will have with the linear static and linear dynamic. According to that we have applied here that forces. And see, also for the wind you will see we have WLX and WLY. So these are the load we have put on the structure, this frame structure. right? Now see, first thing that you have to do, I think you all have aware about the model analysis. You have to perform that model analysis and you have to compare. I have the conventional structure also. I will open that one too. Okay, let me open that one. So hello.
Yes, sir.
Yeah,
So
please.
here you can see the extra factor in this conventional structure that we have put in this shear wall. Why? Because see, when we have done the model analysis, the result is not satisfactory. Okay, that's why we have put this one, right? So now one thing that we want to check here. First thing, that first mode, what we will do. See, we have this extra. We have to put this extra. What you call that, shear wall, right? So to avoid that one, no, no. What I am trying to tell you that I will compare their first step. Okay, their linear dynamic analysis. Okay, so first thing that what we have to do, we have to analyze the structure, right? We have this run analysis. Just wait. Okay, so we are checking the structure without loads, right? There is some minor issue that we have found here, but that is okay. Right now, uh, again we will go here on display. Here you can check the it. Both of you are seeing this table,
Yes.
and here you can see this time period and frequency here. So see why we are comparing this one. So now you can check that what is the benefit by using this Diagrid type of structure. Same procedure we will follow up in this one. Here we have the analyze option. Fine. Again, we will check there in analyze of that in display. We will check their table. The same table that we are checking for the right. So now we have two table. Okay. Let me open that both one. Just wait. Just give me 1 minute. You are seeing the screen, both of you.
Yes, yes.
So here we have result as we concern about their time period and frequency, right? This is very important as we know. See, either you are comparing the structure, either you are comparing the building structure, or either you are comparing any kind of structure. So all the structure have their free mode of vibration. If you just compare one ball, okay, just assume you have one cricket ball. If you throw the cricket ball, so they have the vibration, right? They have angular velocity, they have displacement, right? So that all you can compare a structure with their natural time period and frequency. That are very important part. As you are seeing here, uh, this Diagrid structure, this is the Diagrid one, right? The red color is the Diagrid and the green color is the conventional. So you can just see in first mode, in linear transitional, they have time period of 1.466, and in Diagrid we have 0.9897. So this is the big difference, right? What is their basic difference between their time period? I think that is 0.5 lump sum, right? Hello.
Right, right,
Yes.
right.
Okay, so now you can see the real application of these things. Let me just open this calculator to calculate our value. So the first value is 144 1466 minus 897. Fine. So we have 567. So what is their difference between that is 0.567. Almost this Diagrid structure are giving 35% better result. If you convert into the percentage, that might be the 35. Am I right? Again, if you see the second mode, third mode, that all the modes basically we have to check that three mode. If you have the high rise structure, you can check for the three mode. So first three mode, you can see that structure, their time period and generally their frequency, that time period and frequency that are you can compare. Okay, f is equal to 1 by t by that formula. So you can again see the frequency and time period. Okay, so these are some of the basic outcome of this structure. Okay, so that's why we need to develop this kind of structure for our better performance, right? Now see, I will show you some of other results. See, this will I will upload into the Google Drive, so there you can download and check all the things. Now I will show you. See, as per the deflection point of view, any displacement, any structure have their displacement, right? So next we will check here in display option. We have story response data. So just assume I am applying. Hello, you are seeing that screen?
Yes, yes.
Okay, we have this maximum story displacement. Okay, and I am comparing with this. Just we are going to for the dynamics. Okay, that is earthquake. That is RSX. Okay, so these are the force that are seismic force that are in X direction. So this we have displacement that are for the Diagrid. Now I will open for the conventional. Okay, in the display I will just open that one. So let's see. Oh, sorry, just wait. just wait. Now I will. You are finding this. I think this will quite interesting as per your previous lecture, right?
Yes.
Yes.
I will just save their data. Just wait 1 minute. So now we have the two report. Okay, two report I have generated. Okay, what kind of report we have? So first we have report with the that conventional, and second we have Diagrid, right? So let's see. So see story displacement. Actually, there is some of the formulas you will learn that if we calculate the maximum story displacement, that is allowable displacement for this structure. So generally that is around uh, that is 38 mm. Okay. So first graph you are seeing here, that is with the conventional structure. Okay, both of you. So this
Okay, sir.
conventional structure, you can see what is their maximum story displacement, that is around 32, not 32. They are just here. You can check that this one. Fine. So these are value between, or you can just say it's around 30 mm the story displacement. Now we can check the story displacement for the Diagrid structure. Here you can see this is around 16. There is almost 50% difference. Okay, both of you got it.
And this
Yes.
one, how
Yes.
you are telling, sir? 15.
This is for the Diagrid 15. You are seeing, see
Okay, okay.
the first one you are seeing with the
30.
conventional, that is 30, and for this Diagrid we have all just like 16 mm.
Okay.
Okay, so now you can see this is just this Diagrid structure are giving almost 30 to 50% better result as compared to conventional. Okay, that's why we need to study this all the things. Okay, now see, we have different kind of forces that we have applied here, that load cases. Generally we are studying the load case, right? Now again, if you see for the Diagrid in this in their shapes, just for the super dead load, here we can check that super dead load. Okay, and if you see, this value are in very minor. If you check their story displacement, this value are in less than this. You can see this value are in E. Whenever you are seeing this one, so this is the story displacement as compared to super dead load, that is 0.00547. That is in mm, that is in meter. If you convert that one into the that meter, what will be that? That is very negligence. Okay, that are very in our limit. Okay, so that are the some of the benefit that we have the Diagrid, with the Diagrid. And also not only this displacement, you can also check the story stiffness. Okay, just let me apply. So here you can see the maximum stiffness that we have to check in the that one, that we have to provide, that we have to conclude that the maximum stiffness that will be on the that on story 1, right? So here you can see the maximum stiffness we have on the story 1. Right after this one, what I will check for this is for the Diagrid. Now I will check for the Diagrid, that is the conventional. Fine, let me open that conventional structure and story stiffness and RSX. Okay, you can see that one into the uh, in first one, this we have, okay, and in second type of structure, actually, just wait 1 minute. I get confused. For the conventional and for the Diagrid. One we have 160. Fine. Okay, let me open this one again. Here you can see for this Diagrid one, I think you are aware about the center of mass of the structure. Okay, see, whenever you are comparing, whenever you are seeing the structure, what is their basic fundamental behavior of the structure. So we have two or three kind of, let's see, you know about the center of mass, both of you. So generally,
Ah,
if we have fixed shape geometry, you can calculate center of mass by their formula, right? We have center of mass. Next we have the another term, we have center of rigidity. Anyone know that what is the center of rigidity? That you can say the CR. Okay,
okay.
so see, center of mass is, you know, that if we have the building structure and that are uh, that all the floor are typical, it means that all are similar and you have make with the same quantity of material. So you know that you can assume that their center of mass maybe lie in their middle. Okay, but see, due to the loading, like we have different loading on the structure, you can just see the base part have their base column have more loading as compared to the upper one, or also there the loading pattern are not always same due to the live load. Okay, the dead load are the same, but live load may be changed or other factor that include. So by that external load, our center of mass, as we have calculated by our classical physics, that may not lie on the same point. Okay, so next point we have, that is center of rigidity. So the center of mass and center of rigidity, as if you have to stable your structure, so their distance, it means center of mass and center of rigidity, the distance between them, it means their distance should be minor. That will be uh, there is some provisions you will learn about that one also. So here you can see that displacement that are as compared to that concern of the diaphragm. Okay, you can see we have story displacement here, that is, you can see about 14 point, it means lump sum 16 mm. Okay, as in Diagrid. Let us check in the conventional. Again, if we go in the conventional, okay, RX, you can see here we have almost, that is around that is 32. Okay, so that are the some of the, like you can conclude from this structure. So that we have the Diagrid structure that have better performance. Okay, you can check other things also. We have this overturning moment. Okay, this all you can, we will deliver that all the lectures in our coming weeks and months. Okay, so these are the outcome of this structure. Okay, I will share that all the content of this one for your study purpose. So what is your work in this one? So you have to do some a small unit, a small assignment, you can say. What will be the small assignment? So first thing that you have to make that one, that is one unit of this structure. It means this one you have to try, okay, by the help of this. Okay, both in
Okay.
SAP and in Tekla. So this is your
Okay.
task. You just you have to just complete this one, because see, uh, you require to develop this kind of skills. Okay. In last, if you summarize this all the conclusion of this structure, you can just see maximum study drift, that all things. Here you can see their natural time period. Okay. Their base share, the seismic. In seismic, we have 20696, and here we have 23950. Their wind load also less as compared to conventional, because their due to the aerodynamics, generally the conventional structure attract more wind forces. Okay. In Diagrid, we have maximum moment is 441597, and in this conventional we have like 511010. Okay. So these are the some of the outcomes. So see why this outcome and result we need, because this will give you the exact study about their bending moment and shear force, and their axial force are also. Maximum axial force we have here like 163311, and this we have 83639. Okay. Maximum joint displacement is 15.843, and here we have 36.167. So the chances of failure for this conventional structure is more as compared to Diagrid. Right. Here we have this bending moment, here three mode shape. Okay. Both of you got this in from today lecture. Both of you got the point that what we are concluding.
Yeah, okay, sir.
Okay. Any question?
Actually, you share with this one with a PowerPoint or ETAB file.
ETAB file, PowerPoint also, both.
Both the file you have to share.
Yes, yes, I will share that both. You can see
Okay.
there. This is their three mode vibration of this. Right. I think you can do in ETAB also. Okay, you can see the three mode vibration of this structure, Diagrid structure. Okay.
Okay.
Fine. I will share this all the document, and just study this one and make that a small unit. Okay, that will be better.
Okay, sir.
Okay.
Okay.
Thank you again. We will meet tomorrow. Okay.
Yeah, okay, sir.
Okay.